Okay, prove that the product of any two odd numbers is odd. Okay, so any two odd numbers. Okay, now we could think of odd numbers such as 3 and 5. Okay, now when you work out the product of them, okay, product of course means multiply, you get 15. And of course, the answer there is odd. All right, that's for one pair, but of course there's infinite amount of other pairs. Yeah, you could have 11, 13 times them, right, and that will come out as odd as well. But we want to prove it for all pairs of odd numbers. Okay, all pairs of odd numbers. When we times them together, the answer is odd. In order to do that, we need to sort of look at it algebraically. And algebraically, we can use like the letter n, for instance. So if n represents numbers, counted numbers, such as 1, 2, 3, 4, 5, etc., etc., and there's things we can do with that. For instance, we can think about what 2n would be. Okay, 2n. Now 2n would be doubling it, wouldn't it? So if I double that, I'd get 2, wouldn't I? And if I double n there, because you know 2n means 2 times n, so double that, I get 4. Double this, I get 6. Double this, I get 8. Double this, I get 10. Okay, so you notice then, 2n actually represents even values. Okay, so when you see 2n, you've got to think, oh, that's even. Those are even numbers, all the even numbers. Okay, you can keep on going, right? So if they're the even numbers, what are the odd numbers? Well, you can get odd numbers simply by adding 1 to this, can't you? Because if you think about it, if this is 2n, if I add 1 to it, well, adding 1 to 2, I get 3. If I add 1 to 4, I get 5. If I add 1 to 6, I get 7. Add 1 to 8, I get 9. Add 1 to 10, I get 11. Notice then these are the odd numbers. Okay? So 2n plus 1 I can think of as an expression of an odd number. Okay? Now it says here, prove that the product of any two odd numbers. Okay? So I could think of this representing an odd number. Okay? Suppose to times it then by another odd number. Well, I could think of 2n plus 1 again as the odd number. Or I could even think about 2n plus 3, for instance. All I'm doing is I'm adding, if you think about it, an odd number onto this. So, you know, there's my even numbers there. If I add 3 onto this, I get 5. If I add 3 onto 4, I get 7. If I add 3 onto this, I get 9. If I add 3 onto this, I get 11. If I add 3 onto this, I get 13. Notice again, they're odd. So 2n represents my even numbers. And if I add an odd number onto it, like 1 or 3, I just get a set of odd numbers. So I know 2n plus 1 is odd. I know 2n plus 3 is odd. Now what I need to do is the product of them. So I'm going to multiply them. If I multiply them, okay, I need to do FOIL. And when I multiply these, then I'll have 2n times 2n, which is 4n squared. 2n times 3, which is 6n. 1 times 2n, which is 2n. And then 1 times 3, which is 3. Now that becomes 4n squared plus, that would be, what's that there? That would be 8n plus 3. Now what I want you to notice is, right here, these first two terms here, I can take out a common factor of something, can't I? I could take out a common factor of 4, but more specifically, I could take out a common factor of 2. And if I take 2 out, 2 times, what will it be, 2n squared will give me that, and 2 times 4n will give me that. And then adding on 3. What you'll notice is, right, of course this now has got to be even, isn't it, if you think about it, because it's got a factor of 2. Okay, so this is even. When you add 3 onto it, it makes it odd, doesn't it? Okay, because when you add an odd number, remember, when you add an odd number onto an even number, even plus odd, it gives me an odd number. So this you've got to think here is even, because it's a multiple of 2, plus an odd, even plus an odd, will equal to an odd number. So the product of any two odd numbers is odd. Okay, when I times two odd numbers, it's odd. And just remember, that represents an odd number. This represents an odd number. If you forget it in the exam, do a little table like this, if this comes up. And remember, 2n, always, you doubling the number, always give you even number. Okay, 2n is always an even number. And if you add then an odd number onto 2n, you get odd numbers. It doesn't matter what odd number you add on. So these could represent two odd numbers, multiply them together, and you appreciate then the answer, well, that actually is even, because it's a multiple of 2, and then you're adding an odd number on, so it gives you the answer as being odd.